Welcome to New Findings of the Universe. Just 30 years ago, we had no solid proof that any planet existed beyond our solar system. Not one confirmed world around another star. And now we live in a completely different era. We have discovered thousands of exoplanets, alien worlds orbiting suns that are not ours. Worlds that sit in the darkness of distant systems waiting to be understood. This happened fast, almost shockingly fast. Like humanity suddenly learned how to see in a new color. At first, the discoveries were mostly giants. Massive gas planets that were easier to spot because they tugged hard on their stars or blocked a big slice of starlight as they crossed in front. They were the loudest signals, the easiest shadows to catch. But as our instruments got sharper and our methods got smarter, we started finding smaller planets, rocky planets, Earth-sized planets. And that is where the story turns from impressive to personal. Because once you can find worlds like that, you can start asking the question everyone secretly wants answered. Are there places out there where life could exist? Today, we are going to talk about the scientists who are discovering planets that might be more habitable than Earth. That phrase sounds almost wrong at first, because Earth feels like the definition of habitable. But Earth is not perfect. It has brutal extremes, deep deserts, frozen caps, violent storms, and long chapters of chaos in its history. Life thrives here, yes, but it also fights here. So the real question is not whether there is another Earth copy. The real question is whether the universe has built worlds where life would have an easier time. Worlds with more stability, more protection, and more time. We are going to step into a nearby star system where multiple rocky planets may sit in the right region for liquid water. We are going to talk about super-Earths, about red dwarf stars, about tidal locking, and about why the habitable zone is only the beginning of the conversation. And by the end, you will see why the search for Earth 2.0 is evolving into something bigger. The search for entire systems of potential homes. If you enjoy astronomy told as a real story, subscribe now, and let's begin. To understand what makes a planet potentially habitable, we have to start with the idea that anchors the entire search, the habitable zone. This is not a magical ring where life is guaranteed. It is simply the region around a star where, if the conditions are right, a planet could keep liquid water on its surface. Water matters because it is the one common ingredient in every living system we know. That does not mean life cannot exist without it. It means water gives us the best starting point we have. Round a star like the Sun, the habitable zone sits farther out. Round a smaller, cooler star, the habitable zone moves inward. And that brings us to the most common stars in our galaxy, red dwarfs. They are small, they are faint, they burn slowly. They can live far longer than stars like the Sun. And that sounds like a gift for life, because life needs time. But red dwarfs come with a catch. Their habitable zones are close in, which means any potentially habitable planet is orbiting very near its star. That changes everything. When a planet orbits close, it can become tidally locked. One side faces the star forever in permanent daylight. The other side faces away in permanent night. At first, that sounds like a planet split between burning and freezing. But it is not always that simple. If the planet has a thick enough atmosphere, winds can move heat from day side to night side. The world can develop a stable band of temperate conditions near the boundary between light and dark, like a permanent sunset region where temperatures might allow liquid water. Now imagine finding not one candidate like this, but multiple candidates in the same system. That is where the story becomes intense. Because instead of searching for a single lucky world among countless stars, we start focusing on stars that might offer several chances at once. And we already know at least one system in our cosmic neighborhood that fits this pattern. A system called Gliese 667. It is about a couple dozen light years away. And it is not just one star, it is three. Two of the stars are larger and farther out. But the third star, a faint red dwarf, is where things get exciting. Data suggests it may host a rich family of planets, including several that could be rocky and located in the right region for water. And that is exactly where the idea of worlds more habitable than Earth begins to feel possible. Gliese 667 is a reminder that nature loves complexity. This is a triple star system, 3 suns bound together. 2 are larger, orange-red stars farther from the action. The third is smaller, cooler, and much dimmer, a red dwarf. And even though it is the faintest, it might be the most important, because it appears to host multiple planets that could be rocky. Because the red dwarf is weak compared to the Sun, its habitable zone sits very close to the star, close enough that the entire habitable zone would fit well inside the orbit of Mercury if you placed it in our solar system. That distance sounds dangerous, but remember, the star is faint. A planet can sit close and still receive a similar total amount of energy to what Earth receives from the Sun, especially because much of the light from a red dwarf is infrared. One planet in this system became famous because it seemed unusually promising. It is larger than Earth, but not a gas giant, what scientists call a super-Earth. That term does not mean a perfect upgrade. It means a planet bigger than Earth, with a mass and size that could allow it to hold on to a thicker atmosphere. And a thicker atmosphere can be a powerful tool. It can redistribute heat. It can protect the surface. It can keep water stable. In other words, a super-Earth in the right region could, in some scenarios, be better at staying habitable over long time scales than Earth is. But the same closeness that keeps it warm also introduces risks. Tidal locking is likely. The planet may always show one face to its star. That creates a permanent day side and night side. The climate would depend heavily on the atmosphere. With a healthy atmosphere, heat transfer could soften the extremes and create a broad region where temperatures are stable. Without an atmosphere, the extremes could be brutal. And then there is the star itself. Red dwarfs can flare. Some emit sudden bursts of radiation and energetic particles far stronger than typical solar flares from our Sun. If those flares hit a close planet, they can erode atmospheres and bombard the surface. So habitability becomes a contest. Can the planet hold an atmosphere? Can it shield itself? Can it stabilize its climate? This is why the phrase potentially habitable is so important. It is not a promise. It is an invitation to investigate. And what makes Gliese 667 so fascinating is that it might not be a single invitation. It might be several at once. Now, let's bring it to life. Imagine standing on a world illuminated by a dim red sun. The light would feel like an endless late afternoon. Not bright white, but warm, reddish, and strange to human eyes. If the planet is tidally locked, the star would hang in the same place in the sky, always. There would be no normal sunrise or sunset. The rhythm of life, if it existed, would be shaped by geography rather than time. But the environment would be shaped by physics too. A super-Earth could have stronger gravity than Earth. You would feel heavier. The atmosphere, if it exists, could be thicker, and that could be good or bad. A thick atmosphere can trap heat and prevent the night side from freezing solid. It can also act as a shield against radiation. But if it becomes too thick, surface pressure could be extreme, turning the air itself into an ocean of weight. When scientists say more habitable than Earth, they are not saying humans would instantly thrive there. They are saying life as a broad concept might thrive more easily. Earth has massive oceans, yes, but Earth also has enormous extremes, and it has suffered global catastrophes. A world with a thicker atmosphere, a more stable climate, and a longer-lasting star could offer more consistent conditions over billions of years. Consistency matters. Life can evolve faster and survive longer when the environment does not constantly reset the board. Gliese 667 is especially interesting because multiple planets may fall near or within the habitable zone of the red dwarf star. That is rare. It means a single system could contain several worlds where liquid water might exist under the right atmospheric conditions. It also means scientists can stop thinking of habitability as a single target and start thinking of it as a network of possibilities. But there are boundaries. Too close, and you risk a runaway greenhouse effect where water turns to vapor and escapes. Too far, and the planet becomes an ice world, unless the atmosphere traps enough heat. Even carbon dioxide can help warm, but too much can also reflect light and cool. Habitability is not a switch. It is a balancing act. The big idea is this: we are not just finding planets. We are learning how many different ways a world can be friendly to life. And as we discover more compact systems around red dwarfs, the number of potential habitats in our galaxy may be far larger than we once believed. Here is the statistic that changes everything. Red dwarfs make up the majority of stars in our cosmic neighborhood. That means if red dwarfs can host habitable planets, then the galaxy might be filled with them. It could mean that instead of hunting for one rare Earth-like world around sun-like stars, we may find many potentially habitable worlds around small stars, simply because small stars are everywhere. But the red dwarf question is complicated. Many red dwarfs are active, especially when they are young. They flare, spit energetic particles. They can strip atmospheres from close planets. This is why scientists care about a planet's magnetic field and atmospheric strength. A strong magnetic field can deflect charged particles. A dense atmosphere can absorb radiation. Oceans can provide shelter. Life on such a world might not live on open land under the sky. It might live in water, underground, or in protected regions. And there is another twist. Red dwarfs emit less ultraviolet light, and ultraviolet light can help drive certain chemical reactions. Less ultraviolet might slow some pathways for life, or it might reduce surface damage. We do not know yet. We are learning. That is why systems like Gliese 667 are so valuable. They are close enough to study. They give us multiple planets to compare. They force us to refine what we mean by habitable. And they help us shift from a myth idea, one perfect second Earth, to a scientific strategy. Many candidate worlds with different advantages and risks. This is also where new telescopes change the game. We are moving from the discovery era to the characterization era. It is one thing to detect a planet's mass and size. It is another to detect its atmosphere, to measure its spectrum, to search for water vapor, carbon dioxide, methane, and combinations that could hint at active chemistry. We are not promising life, but we are getting closer to asking the right questions in the right way. Every time we find a planet in the habitable zone, the headline is easy, but the real story is harder. What is the atmosphere? What is the star doing? Is the planet locked? Is it protected? Is it stable? Those are the questions that separate a hopeful dot on a chart from a world that could actually host life. Now we are going to step back and ask the bigger question. If Earth is not necessarily the best possible design for habitability, what would a better one look like? When people hear more habitable than Earth, they often imagine paradise, but scientists mean something more specific. They mean a world that has conditions that might be easier for life to sustain over very long time scales. That could include a more stable climate, more consistent surface temperatures, stronger protection from radiation, and a star that stays calm and steady for billions of years. Earth has many strengths. It has liquid water. It has plate tectonics that recycle carbon. It has a magnetic field. It has a large moon that stabilizes its tilt. But Earth also has dramatic swings and violent chapters. It has experienced mass extinctions. It has shifted between ice ages and warm periods. Life survived, but those shifts are disruptive. A planet with fewer extremes might allow life to diversify more smoothly. A slightly larger rocky planet might hold on to internal heat longer, sustaining geological activity and magnetic protection for more time. It might hold on to its atmosphere more effectively. It might maintain stable oceans and climate longer than Earth can. These are the reasons super-Earths in habitable zones are taken seriously. But again, in a system like Gliese 667, the star environment complicates the story. A calm, long-lived star would be ideal, but many red dwarfs flare. So scientists must consider whether the planet has enough shielding to survive that environment. And they must consider whether the planet can hold on to an atmosphere at all. This is where the science becomes honest. We do not know the surface conditions of these worlds yet. We have mass estimates, radius estimates, orbital periods, energy received. But we do not yet have direct measurements of clouds, oceans, continents, and pressure. We infer, we model, we compare scenarios. And even the planet lists can be controversial. Some proposed planets are debated. Signals can be confused with stellar activity. Detections can be refined or rejected as more data arrives. That is not weakness. That is science doing its job. The big shift is this. The universe is telling us that habitable worlds might not be rare single prizes. They might come in clusters. In systems where multiple planets sit near the right region, and where slight differences in atmosphere and orbit produce different climate outcomes. Some may be too hot, some too cold, some may land in a sweet spot. And as telescopes improve, we will move beyond guesswork. We will start measuring atmospheric chemistry. We will start seeing whether these planets have thick envelopes of gas or thin, breathable-like layers. We will start narrowing the list from possible to plausible. That is when the conversation about life stops being speculative and becomes evidence-based. For most of human history, the night sky was a mystery filled with lights. Now we know those lights are suns, and now we know many of those suns have worlds. The galaxy is not just stars. 'Tis neighborhoods. It is architecture. It is countless versions of what a solar system can be. Systems like Gliese 667 are powerful because they are close and because they may contain multiple potentially habitable worlds. That means we can study a single star and learn about several planetary climates at once. It also means habitability may be less like finding one needle and more like finding the right haystack. And red dwarfs offer something profound. Time. They live long. They burn slowly. They can remain stable for trillions of years in some cases. If life needs long stretches of time to evolve complexity, red dwarfs could provide the runway. That is why scientists do not dismiss them, even with flare risks. Because if even a fraction of red dwarf planets can protect themselves, the number of potential habitats in the galaxy could be enormous. At the same time, these worlds would not feel like Earth. A tidally locked planet could have a permanent day side and night side. The light could be red. The seasons could be weak or strange. The biology could be adapted to infrared. The ecosystems, if they exist, could look nothing like what we know. And that is part of the excitement. The universe does not owe us familiar. It owes us variety. So when we say more habitable than Earth, we are really saying something humbling. We are saying Earth is our home, but it might not be the best possible template for life everywhere. Other worlds might have larger stable oceans, gentler climates, thicker protective atmospheres, and longer-lasting suns. They might be better at giving life a steady stage. And the next step is close. With modern observatories, we are learning to read atmospheres by the way starlight filters through them or reflects off them. We are learning to detect gases and clouds. We are learning to turn distant dots into real physical worlds. We are not there yet, but we are moving from the age of discovery to the age of understanding. And when that happens, the question will not be, can life exist? The question will be, where is the strongest evidence that a world is truly alive? So here is where we stand. 30 years ago, no confirmed exoplanets. Today, thousands. And within that growing map, we are finding planets that are small, rocky, and placed where liquid water could exist under the right conditions. We are finding systems that may host more than one potentially habitable world. We are realizing that Earth is not the only way to build a habitable planet. That is what makes this era so thrilling. We are alive at the moment when the universe is becoming crowded with possibilities. Not because we are inventing them, but because we finally have the tools to see them. Gliese 667 is one example. A nearby system with a faint red dwarf that may host multiple candidate super-Earths in or near its habitable zone. It is a reminder that the galaxy may be filled with compact systems where habitability comes in groups. And it is a reminder that the most common stars in our neighborhood are not sun-like stars. They are red dwarfs. If red dwarfs can host habitable worlds, then the number of potential habitats could be far larger than we ever imagined. In the coming years, the biggest change will be atmospheres. We will stop guessing and start measuring. We'll learn which planets have thick climates and which are bare rock. We will learn which stars are too violent and which are calm. We will learn which worlds can hold on to water over deep time. And as that happens, the phrase "more habitable than Earth" will stop sounding like a headline and start sounding like a serious scientific possibility. Now, I want to hear from you. If we discovered a planet that is truly more stable and more life-friendly than Earth, would that inspire you or unsettle you? And what kind of world would you want to explore first? A tidally locked red dwarf planet with a permanent sunset band, or a larger super-Earth with deep oceans and thick skies? Tell me in the comments. If you enjoyed this, subscribe to New Findings of the Universe and turn on notifications. We are going to keep tracking the newest discoveries, and we are going to tell the story of the cosmos the way it deserves, as something real, vast, and still unfolding. See you in the next video.